All right, here's section 8.3, and our learning targets for the section are to graph quadratic functions of the form f of x equals ax squared plus bx plus c. So in section 8.1, we looked at just having this first term, this ax squared. Then in 8.2, we added this constant, this c value in, and now we're looking at an entire quadratic function in standard form. And then our second learning target is we're going to find maximum and minimum values of quadratic functions. So here's our core concept. So when I'm graphing this quadratic in standard form, here are some things that I need to know. So I know that the graph opens up when a is greater than 0, right? If this is positive, I know it's going to open up, and it opens down if this is negative. The y-intercept, where it crosses the y-axis, is this c value, right? That's what we kind of looked at in the last section. But that's always going to be my y-intercept. And I know that is because my y-intercept happens when my x is 0. So if I plug in 0 for both of these x's, I end up with this c value. So my y-intercept is c. So now I have to find the vertex. The first thing I always want to do is find the vertex. So the x-coordinate of the vertex is negative b over 2a. So I have to find my a and b and c. And I always use this negative b over 2a. And that is also, remember, the axis of symmetry is x equals that same value. So then to find the rest of my vertex, right, I find the x value, which is this negative b over 2a. Then I plug it in wherever I find an x, and I will find the y value of my vertex. So we're going to look at some examples of that. So here's my first example. Find the axis of symmetry and the vertex of the graph of f of x equals 2x squared plus 8x minus 1. So the first thing I always want to do is make sure that I'm written in standard form, which I am. So now I know that my a is going to be 2, my b is 8, and my c is negative 1. And I know that I'm going to have negative b over 2a. This right here is something you really need to get in your mind because we're going to use it over and over and over and over again. It's always how we're going to find our vertex. So now let's go ahead and substitute. So I've got a negative, and my b was 8 over 2, and my a was 2. So now I always want to use parentheses when I'm substituting so I don't lose any negative signs. So now I can simplify. So I've got negative 8 over 4, which simplifies into negative 2. So this value right here is my axis of symmetry. So my axis of symmetry is x equals negative 2. So whenever I write my axis of symmetry, it is a line, so it needs to be written as such. I can't just write negative 2 as the axis because it's x equals negative 2. So this right here is my axis of symmetry. So now I'm also going to take this point, this x value, and put it back into my equation. So now I've got, let me use a different color here, 2, and then my x was a negative 2 squared plus 8 times that negative 2 minus 1. So all I've done, you see, is I've taken this x that we found and plugged it into my original equation. So now I know I've got 2, and a negative 2 squared is 4. 8 times a negative 2 is negative 16 minus 1. So now I'm going to go ahead and multiply here. So 8 plus a negative 16 minus 1. So 8 minus 16 is negative 8, minus a negative 1 is negative 9. So now I can write my vertex. My vertex, which is the point where the graph changes direction, is going to be that x value, which was negative 2, and then the y value, which was negative 9. A couple other things I know about this graph, right, is this a value is positive, so I know it's going to open up. So now I know my vertex, and I know that it opens up. So on this next example, we're going to talk about some domain and range as well. But first, I want you to try these and see if you can find the axis of symmetry and the vertex. Don't forget negative b over 2a. You're going to use this over and over and over and over again. This is the big important thing to remember from this section. Okay, so now we're going to actually graph this. In the previous example, we just found the vertex and the axis of symmetry. Now we're actually going to be graphing, and then we have to find the domain and range. So the first thing I want to do is I want to find the vertex, right? So number 1 is find the vertex. And so I use my a, which is 3, my b is a negative 6, don't lose this negative sign, and my c is 5. So I have a negative b over 2a. So a negative b, which was negative 6, over 2 times 3. So I have a negative of a negative is a positive 6 over 6 equals 1. So this, don't forget, is also the axis of symmetry. If I have x equals 1, So that's the axis of symmetry. So now to find the rest of my vertex, I go ahead and I plug this 1 into my original equation. So I've got 3 times 1 squared minus 6 times 1 plus 5. Well, I know that 1 squared is 1 times 3 is 3. 6 times 1 is 6 plus 5. 3 minus 6 is a negative 3 plus 5 gives me 2. So now I know my vertex is at the coordinates 1, 2. So this helps us. So now I found my vertex. So now, just like we did before, I make a table of values. Okay? But the cool thing here is I now use my vertex to help me with my table of values, right? So I always find 5 values. And in our previous examples, we always used 0 as our middle one, and then a couple to the right and a couple to the left. Well, now we're going to use our vertex as the middle term. Okay, so I'm going to have 1, so now I'm going to look at 2 and 3, then I'm going to look at 0 and negative 1. So now I go ahead and put these in to my equation up here, and I find that when I have an x of 0 or an x of 2, my y value is 5. When I have this 3 or I have a negative 1, my value is 17. So now I have 5 points that I can plot on my axes, and then I can graph. So let's go ahead and graph these. Let's look at them. Okay, so I'm just going to go ahead and erase kind of what we've done. Don't forget it, just so I can click and we can see the example and the graph so it actually fit. So here's my axis of symmetry, which we found. Now we plotted the vertex. We're re-adding the function, so there's my vertex. They found 2 more points on the graph, but the points that we found also work, right? And then we draw our smooth curve. So now let's find the domain and range, because we were asked about the domain and range for this equation, okay? So the domain is always going to be all real numbers, and I can write it like this. So it's all real numbers, or x equals all real numbers. So remember, domain is always my x values. So my range values, my range is the y values. So I see here that y, since my graph opens up, it's going to be greater than or equal to, and then I find that y value of my vertex, because that is also going to be the value that I use for my range. So you see here that my y value of my vertex is 2. I also know that that is going to be involved in my range as well. Okay, so try these. The biggest thing to keep in mind here is figuring out the domain and range. With the range, right, the domain's always going to be all real numbers. The range can change. Does my graph open up or down? Because if the graph opens down, then it's going to be y is less than or equal to that value that we found for our vertex. So see what you can do with these. So now here's our next core concept, and this is that second learning target that we're talking about today. So finding maximum and minimum values. Okay, so the y-coordinate of the vertex is the maximum or the minimum. So when you see a problem and it says what is the maximum or what is the minimum, you're going to be finding the y-coordinate of the vertex. That's the biggest part. That tells me the biggest amount or the lowest amount. And don't forget that when a is less than 0, right, when there's a negative out front, it's going to be a maximum value because my graph opens down. And if a is positive, it's going to be a minimum value. It's the smallest value because my graph opens up. So just remember again, we're looking for the y-coordinate of my vertex. So now let's look at this one. So the first thing, tell whether this function has a minimum value or a maximum value, then find the value. So the thing I notice is that I have this negative sign here in front of my a value, so that tells me that my graph opens down. So that also tells me that I'm going to have a maximum value. Okay, so now I have to find the value. So how I can do that is I use my a and my b to first find the x coordinate, right? I always have to find my negative b over 2a, always have to start here, and simplify. So I've got a negative of a negative 24, and then 2 times a negative 4, which gives me negative 3. So that's the x value, but that is not the maximum value. I'm asked to find the maximum. So I go ahead and I substitute this in. Wherever I see an x in my original equation, I substitute in, then I simplify. And so this 17 is going to be my maximum value because this is the y value of the vertex. So that is my maximum value. So we can also use this in real life situations. So the suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola. Remember, a parabola is the math word of the shape that this forms. That can be modeled by this equation, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So the first thing I want to think about is I'm dealing with feet, so I can't have any negative values, right? I can't have negative feet, I can't have negative distance. I also see that everything is going to be positive, so that just helps me to look at this. I also see that this A value is positive, so I know my parabola opens up, which I can also see in my picture. And so I'm looking for the minimum. So what is the height of the cable above the water at its lowest point? So that's my minimum value that I'm looking for. So again, I find the values of my vertex using my A and B from my graph. First, I always use my negative B over 2A. I substitute in what I know and use a calculator. So this is the X value. This value tells me how far across the bridge do I go to get to that lowest point. It does not tell me the height of the bridge. It tells me how far do I have to go to get there. So now I substitute that back into my original equation to find the y coordinate of my vertex, or the height. So the cable is about 203 feet above the water at its lowest point. So again, I used the vertex and my negative b over 2a to find some information from a real life problem. So here's your next monitoring progress. Try them out and see what you do. We've got one more example to go. So now here, a group of friends is launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it's launched. The height of the second water balloon t seconds after it's launched is shown in the graph. Which one went higher? Well, so I know that this first one, right, still has this negative value, so it's going to be that way. Kind of like this, and I see that this one has its maximum point about here. So in order to compare these, I have to find the maximum of this first water balloon. So that's what we're doing here. So if you're going through taking notes, this is something we just read and think about, right? Which we just did, knowing that this opens down, we're going to compare the heights, we're going to compare the maximums. So we're going to solve them. What we can do is we can put it in our calculator and figure it out, and we see that the height is there. What we can also do, right, is without this graphing calculator, we're going to go ahead and solve it mathematically. So let's write this out. Negative 16t squared plus 80t plus 5. So I need to find the maximum here. So in order to find the maximum, I find the vertex, which is negative b over 2a. So I've got my negative b, which was 80, over 2, and my a is negative 16. So now I've got negative 80 over a negative 32. So I see that both are negative, so it's going to end up being positive, and I see that both are divisible by 2, so let's simplify. So if I divide by 2, this is going to be 40 over 16. Well, now I see that both of these are divisible by 4, so let's continue to simplify. So I've got 10 over 4. Well, these are both divisible by 2 again, so I've got 5 over 2. So now I know I can't simplify this fraction any further. But this is not the final thing that I'm looking for. This tells me after how many seconds I've reached my maximum, but it hasn't figured out the maximum yet. So now I go ahead and I plug that back in. 5 over 2 squared plus 80 times 5 over 2 plus 5. So the first thing I have to do is I have to square my fraction. So when I'm squaring a fraction, I square the numerator and I square the denominator. And then I'm just rewriting what I've got. So now let's go ahead and do the multiplying. And I like to simplify my fractions before I multiply them, because I know that 16 is divisible by 4. So now I end up with a negative 4 times 25, which is a negative 100. 80 is divisible by 2, so now I'm left with 40 times 5, which is 200, plus 5. So negative 100 plus 200, which gives me 100, plus 5 is 105. This tells me the height of that water balloon, which is the same thing I got from looking at my graph. So now let's compare, right? Because I was told to compare them. So which water balloon went higher? Well, I know that the first water balloon went to a height of 105. I see here that the second water balloon, if each mark here is 25, went over 125 feet. So I know that the second balloon went higher. right? And I can find that also from my graph because I marked them as well. So now let's look back at our learning targets. Okay. So our first one was to graph quadratic functions of the form ax squared plus bx plus c. The big thing to remember here is negative b over 2a. This will get you your x value of your vertex, and then you can find your y value of your vertex, and then you can pick points. And then we were able to find maximum and minimum values of quadratic functions. And remember that the maximum or the minimum is the y value of the vertex. So here we're really looking to find the vertices of these quadratics, and then we can graph them and find their maximum and minimum values. So now I want you to go ahead and work on the homework for 8.3.